Hi guys, I'm Aaron, and today what we're going to be doing is we're going to be going over a Type 2 two-line threading can cycle. We're going to be using a Fanuc program, and we're going to be running it on a Siemens control, okay? So like on the other video, you saw that there was a G291 at the very top of the program. If you're only running a threading program, you can very simply just come up here and put a G291 into your program. All that does is take your machine and converts it from reading Siemens control to Fanuc control. Okay, so the threading can cycle, this is what our program will look like. There's a lot here, but having a two-line can cycle is nice because you can control a lot of what happens during this code. All right, so let's go ahead and look at our part. You'll notice that we have a 1-inch 8 2A. Okay, so if we look at our material, we'll see that it says 1-inch, 8 threads per inch, UNC 2A. And one thing we'll have to remember on our can cycle is that we're not going to program it to 1 inch, and I'll show you what that's going to be. Okay, so let's go back to our code after we defined our clear point. So anytime we're running our part, we want to have a clear point right here. Okay, so that clear point, if you'll notice, is above 1 inch in diameter, but don't put it at 2 inches or else you're going to be watching that machine cut air for a really long time, and I'll explain why in just a second. So we'll go back to our program. So the first thing I want to do is I want to go to my clear point. Okay, so this clear point, like we just established, is 1 inch 25 thousandths. When I'm coming to a thread, it doesn't matter what the diameter is. If it says it's a 1 inch diameter, I usually stay about 25 thousandths above that call out, okay? Because when I start adjusting my tool down, if I adjust it down too far, then whenever it cuts the threads and it comes back and retracts, it's going to retract over the top of my threads, therefore damaging and scrapping my part. So I want to give it just a little bit. Don't give it like a whole 2 inches. You just want to come up a little bit because that's going to be our safe zone. All right, and we're 100 thousandths in front of the part and not at Z0. That gives the tool a second to get to its safe position and then kick on. All right, so let's go into this G76 code. So G76 has a P03. All right, so this first 03 is all going to be defined right here. So it's going to be finished passes. So once my thread insert makes it to this 849 thousandths, that is the minor diameter of my thread. Once I make it there, that tool will do 3 passes at that 849 thousandths dimension. All right, so the next thing I'll have on here is I have 00. That is the amount left at the bottom of the thread. So think of a G71 can cycle where our U leaves a certain amount of material for the finish pass. That's what we would do here. So if I have a roughing threading tool and then I have a separate finishing threading tool, that way that finishing threading tool can come back and remove that remaining amount of material. Okay, so that's all it is, but we leave it at 0. Those 3 passes that we established, I think we'll get rid of the most of what we have. So then I have 60. All that is the standard V thread angle. That's all it is. And if it was a 30 or 90, it's whatever angle of thread you're using. Whatever insert you're using, that's usually the style you'll put on there. Okay? So, and then we have this Q. I want to touch base on this for a second. Now, this Q is 100, but what does that 100 represent? So every machine has something called a pulse. So every time a machine pulses one time, that is 1/10 of an inch. So if I want to take a 10 thousandths pass right here, if I want to take a 10 thousandths pass, I have to take 100 times a tenth. That gives me my 10 thousandths. Or I could do 0.010 and divide it by 1/10, which is 1 pulse. Okay, so you can do it either way. Either way will work, and that's what I'm going to put right there. Okay, so now the second line of my G76 looks a lot like a Type 1 can cycle. What I mean by that is most of our variables are the same. Okay, I have a G76, I have an X 849 thousandths, but where did that number come from? Okay, so let's go look at our thread, and it's a 1-inch 8. So we're going to be right here on my 1 inch. So I'm at a 1 inch 8 UNC. Now it was a 2A, correct? So I'm going to come all the way across here, and it's going to do my value right there, okay? So where did that come from? So I've got external thread, I've got a major and a major diameter. This is what it can be. And then I've got a pitch diameter. We'll use our gauges to check that. And then I've got our minor diameter, okay? There it is right there. We got 849 thousandths. That's where that number comes from, okay? Now this number right here, this is our major diameter. We established that when we're running our G71 can cycle. Kind of weird. We actually established part of our thread in another part of our program, okay? And for this example, I made mine 990 thousandths, okay? That's just right inside that range. So in case I didn't cover it, that's what that number was. It's not a solution or any math. I'm just picking a number that is in that range, okay? So I have my 849 thousandths. That's good. That's what we want. Let's get rid of all this. Okay, and then we'll come back to my program. There we go. So now I come back to my program, and I'm going to establish my Z. Okay, so this Z is 1 inch 450 thousandths back. Okay, so what that means is I'm looking at my program. We'll just look at our part real quick. And so I have this groove right here. So if I take 1 inch, if I take 4 inches 300 thousandths and subtract 3 inches from it, that's going to be 1 inch 300 thousandths, okay? But I don't want my grooving tool, let's make a grooving tool, okay? I don't want that grooving tool to stop right there, because if you notice, I didn't stop at my groove. Now the reason why it stopped right there is because my tool, whenever I set it off, set to 0, it was right there. The left side of my tool was on the front of my part, okay? That's nice because when we're establishing the final Z location, we're not doing any guesswork. If I want this tool to go back 1 inch 300 thousandths, I know exactly where it's going to be. Now if I was to tell it to go to this variable right here, that would be 1.5 inches, okay? 1 inch 500 thousandths back. Now if I put that number in there, there's a chance that it might run into the shoulder, not by very much, but I don't want to do that because it is hard on my insert, okay? So what I would do is I would just move it, and this is what I usually do, is I usually just move about right there. So I got about 50 thousandths gap right there. It could be 25, it could be 10, I mean it could be all the way to 100, but then I want to make sure that I am stopping in that groove, okay? So with that said, I would make my variable, which would be 1 inch 300 thousandths, and if that's 1 inch 500 thousandths, I'm just going to take that and subtract 50 thousandths from it, okay? So 1 inch 450 thousandths will put my tool right there, which is well within the groove, okay? So that's how we define or how we figure out that variable, okay? So let's go back to our program. There's our 1 inch 450. Here is our thread height. The P is our thread height. Now if you want a quick way to find that out without going to a book, you just take that diameter that we looked at, that 990 thousandths, and then I subtract 849 thousandths, okay? That number divided by 2 will give me my P. Now my P might be just a little bit different. It can vary by a couple thousandths. Remember when I talked about adjusting the tool down, that's where you dial that in, okay? So that's that where column's 4. So that's a quick way to get your thread height. And then I have something else. I have another Q right here, okay? So the Q, now we have depth per pass up here, but I have another Q, which is the initial pass. The first pass that my grooving tool or my threading tool makes is going to be defined right here. And then every pass after that will be defined with this Q up here. So I just went the same amount. I went 10 thousandths. If I was running stainless steel or harder metals, I'd probably go about 5 thousandths. That way it's a little bit less strain on the tool. It gives me a better finish, okay? But for aluminum, this will be just fine. My R is for thread taper. So if you're doing pipe threads, this 2-line can cycle works really well because you just put whatever the angle of the pipe thread is and you don't have to think about it, okay? You're done. And the last thing is going to be my feed rate. Now how I calculate my feed rate is going to be 1 divided by threads per inch. So 1 divided by 8, and I just happen to be lucky, it won't always work out that way, equals 125 thousandths, okay? Equals that number right there. That's how far the tool is going to advance onto the part every rotation, every revolution, okay? And that's kind of it. I mean, that's all we're looking for right there. So we've established what all these mean in our parentheses. We've established our clear point. And remember, once this tool is done moving, okay, once it is done moving or executing this code, the tool will move back to my clearance point, okay? So with that said, if you have any more questions, come holler at me. Again, my name is Aaron Rump. Thank you for watching.